Energy. What is it? Where does it come from? Where does it go? What happens to it? You guys think about energy a lot, whether you know it or not. You think about the energy you get from food. You think about the energy you get from an energy drink. Not so healthy. You think about energy from wind. You think about electricity. You think about batteries. You think about chemicals. You think about, well, you think about a lot when it comes to energy. Probably energetic people. Now, what is energy? Particularly, we're looking at two questions here. We're looking at what is energy and how does work come into play when we're talking about energy. Okay? So here we go. What is energy? Bottom line, energy is the ability to do work. If you can't do work, you don't have energy, right? Or if you don't have energy, you can't do work. But in physics, work, which is capital W, is actually defined as a force times a distance. Okay? We're going to talk more about that. But work, you're applying a force over a distance, or maybe you're lifting something. You've got an object and you're lifting it up. You have to apply a force in order to lift it, and that's going to move up a certain distance. That is work. You're putting energy into it. Okay? Energy is the ability to do work. All right. Now, how does work come into play? Again, work involves change. Change. When I push on something, I'm giving it energy, I'm changing its motion. When I eat something, that energy is in a potential form, it turns into energy, which then I change that into movable energy where I'm moving stuff around. We'll talk more about that stuff later. But it involves change. You can talk about change such as melting ice. You're taking something that's solid and turning it into a liquid. That takes energy. That's a change. It's changing state. You can talk about speeding up in a car. You're changing the motion. Work and energy involves change. Now, in order for work to happen, you have to transfer energy. When you melt ice, you're transferring thermal energy from your hand onto the ice cube, or maybe it's in a pan and you're transferring heat energy from the pan to the ice cube. The ice cube is absorbing it. If you're talking about a car, you're speeding up. The energy is coming from the gasoline going into the engine, well, actually, chemical energy in the gasoline moves the pistons. When it explodes, that goes to the wheels, which makes you move. You're transferring energy from the engine, from the gasoline to the car. Okay. Last bit here, important part, is that energy and work, both of them are measured in joules. That's named after James Prescott Joule. Basically, a joule is how much energy it takes to take 1 gram of water and increase its temperature by 1 degree Celsius. That's not the most important thing to remember now, but note that it is a unit of energy. It is the unit of work. Okay? Just like meters per second is for speed, feet is for distance, or meters is for distance. That's the unit for energy and work. Okay. Two forms of energy. Okay. If you look at all the energy out there, you can basically knock it down into two different forms. We've got potential energy and kinetic energy. Okay? Potential and kinetic. Now, they actually sound, potential is defined by what it sounds like. Okay, that didn't make sense. Let me explain. Potential energy is just stored energy. Okay? Stored. It has the potential to do something. Think about if you take a spring and you compress it. You're pushing energy in. You're storing that energy in the spring, and then if you let it go, the energy releases. Rubber band. You move the rubber band out. Okay? You're storing energy in that rubber band, and then you let go, flies. Then it's got actual kinetic energy. But potential energy is stored energy. It could be the energy of position. For example, if I take my little pen here and I pull it up, the higher I have it, the more potential energy it has. The more potential it has to hit, to fall, and then hit the table. If I hold it really high, I'll fall. The higher it is, the faster it'll be when it hits the desk, and then the harder or the more work it will do on the desk. That's potential energy. You could call it the energy of possibility of motion. Okay, because I eat food, I have chemical potential energy, which can possibly become motion eventually. Right? Other way to look at it is that it's the ability to do work via, or via, by way of, energy that is stored in the object. In the object. That's potential energy. Okay? Then you've got the kinetic energy. That's what you normally think of. That's the energy of motion, things that are moving, kinetic. Something that's kinetic is moving. Someone with a kinetic personality is moving a lot. Kinetic energy is the ability to do work via mechanical motion. Notice, potential energy is the ability to do work, and kinetic energy is the ability to do work, except they do them differently. Potential is the energy stored in the object. Kinetic energy is via mechanical motion. So they're both the ability to do work, but, whoops, I just deleted, oh well. But kinetic is through mechanical motion. Also, kinetic energy is dependent on the mass and velocity of the object. Think about it. In order to get things moving, or you think about if something hits you, how much work does it do on your body? Well, that depends on how heavy the object is and how fast it's moving. Okay? I'd rather get hit by a baseball going the same speed than a bowling ball, right? Because it's got less mass. Okay? However, if I've got two baseballs, I'd rather get hit by the one that was just dropped on me from a meter above the floor as opposed to one that was thrown at me and going very, very fast, right? And that's got the equation Ke equals 1/2 mv squared. The idea is that the kinetic energy of the object, you can calculate that by taking the mass, multiplying it by the square of the velocity, we'll talk more about that later, and then dividing it by 2. Okay? But there's a mathematical way to calculate it. Let's talk about potential energy and the forms that it comes in. So there is potential energy and there's kinetic energy. Let's talk about the forms that they come in, okay? So if we talk about potential energy, we've got a couple different forms. You can have chemical potential energy, nuclear potential energy, stored mechanical potential energy, kind of sounds like kinetic, but it's not, or gravitational potential energy. Okay? Now, if you go to chemical, what we're talking about is energy stored in chemical bonds. Okay, this could be in coal. Coal's got a lot of energy. If you take a lump of coal, it's got energy stored in those chemical bonds. If you find a way to release it, you get heat, and then you can eventually make electricity, etc. Gasoline, same thing. You blow up some gasoline, you ignite it, and you get energy. You get more heat, which you can then use for other things. Food is chemical energy. When you go to lunch in the cafeteria, you are consuming chemical potential energy. This allows your body to do the things that it needs to do. All right. Nuclear energy. That's energy that's stored in the nucleus of an atom. If you split it, it releases. It's different from chemical because chemical, you're dealing with more chemical reactions. Nuclear, you're actually breaking apart the nucleus. Chemical, you're breaking apart molecules. Nuclear, you're breaking apart atoms. Then there's stored mechanical. It's motion energy that's been stored, okay, like in a spring or a rubber band. That's what I was talking about. It's mechanical. It's moving, physical moving of objects, but it's stored in something. Or, lastly, gravitational. Like I said, energy due to an object being held above the ground. Okay, it has the potential to fall and do work or transfer energy to whatever it hits. All right. Let's talk about kinetic energy. What forms does kinetic energy have? There's radiant, mechanical, electrical, thermal, and sound. Okay? Radiant energy is the energy that's traveling via electromagnetic waves. You're talking about X-rays, UV rays, visible light, microwaves, radio waves, anything that's on the electromagnetic spectrum, which I think you can see over there. Okay? That is energy that comes from the sun, energy that comes from your microwave that heats up your food. That's actually kinetic energy or radiant energy, which is kinetic energy. Mechanical energy is the moving objects, like I talked about. If I throw this marker at you, it's moving, it has that moving energy. If I'm talking about electrical kinetic energy, it's really based on the movement of electrons, okay? Lightning is a movement of electrons from the ground to the cloud. Yes, ground to cloud, promise you. Or electricity. Your laptop right now is moving billions and billions of electrons around in its CPU and from the battery to the computer. It's moving all that stuff. That's electrical kinetic energy, okay? Whenever you shock somebody, you're transferring energy from you to that person. Thermokinetic energy, that's the movement or vibration of molecules. See, I've got a mug of hot coffee here, and this mug of hot coffee has atoms that are moving around, wiggling and jiggling. Now, as this cools down, those individual molecules, they actually move more slowly and more slowly as it cools down. So thermal energy is when it heats up. So if I boil this coffee, it's got more thermal energy. I just said that. More movement or vibration equals higher temperature. Lastly, sound energy. Whenever you make a sound, you're moving air. This is why if you have a demonstration, if you take a bell that's ringing and you put it in a jar that you can suck all the air out of, guess what happens? It stops. It continues to move and it continues to ring, but you can't hear it anymore when you suck out that air because sound needs air to move through. My voice is moving the air, vibrating the air, which is then vibrating the air out here. It's hitting the microphone, and the microphone actually has a membrane that is vibrating, much like your headphones do. It's vibrating, and it's storing that electrically into the computer. Okay? So, that's energy. That's the basic first thing that you need to know, first stuff that you need to know about energy. If you have any questions, make sure you write them down so we can talk about them tomorrow and be ready for class the next day.